Hey everyone, welcome. We're just starting off with some crazy news about UFOs, but we can talk about that later. 1 second. So hope everyone's having a great week. I hope, how was the midterm? Was it okay? Me? So? Okay, well, I'm sure you all did wonderfully. So we're kind of winding down here, getting close to the end. We have this lab, lab 7, and then we have lab 8, and that's our last lab session. And you have your lab practical in a few weeks, so we can talk a little bit about that, probably more next week. Oh yeah, I'm seeing that the midterm was a lot. Yeah, I know. These ones are rough, for sure. It's a lot in a very short amount of time. Okay, so before we jump into talking about trophic interactions, trophic cascades, all this fun stuff, does anybody have any questions they want to talk about for post-lab 6 or for pre-lab 7? And then I can kind of tell you a little bit about the structure of the lab practical, but hopefully I'll know more next week so we can go over it a little bit. So do we have a lab on week 10? No. The schedule for everything should be in the Learning Tree lab manual, but so we have lab section this week, then next week, and then after that, there's lab practical the week after, and then the final, I believe the last week. I'm not sure what day the final is on, but we won't have a lab section, sadly. I'll miss you all. Okay, so I'm getting some questions from 9th is the final for this class. Okay, so I'm getting some questions about lab 6. Getting the data from lab 6. So for getting the data from lab 6, let's see, let me get up the learning tree over here. So for getting the data, this is the data collection for your the panels that you have. So if you have the lab kit, you're going to be using these little sheets of paper, and this is the data that you are going to be collecting on this data collection in lab 3-month panel. There's the 3-month panel, the 6-month panel, and then the 9-month panel on the back, and you'll be filling this in. And then for where the rest of the data is, if you are on this lab 6 kind of drop down, the last thing to click on in lab 6 is this lab 6 data, add your data to this data sheet. And so you're just gonna download lab 6 data for spring 2021. I think I already have it downloaded. One second. Yeah, so this lab 6 data, and then this is where you'll put in your data, number of species, like 3, 6, that, and then you can get the averages for your graphs. Does that make sense? Janelle? Okay, great. Don't save. Okay, so that's for that question. And then I see, how do you get panel surface B? So so are you talking about this percent cover on panel surface one? Yeah, so this is what we talked about with, did they have this on here? data collection tutorial. So this is also, would be a good video to check out. And then do they have the plates? So I'd recommend checking out this video and then checking out, if you haven't watched our lab session recording from last week, I recommend that. But I'll just quickly go over it again, because I think that the percent panel cover is definitely a little confusing. So when they're talking for column A, which is just total cover, you're going to be like, any of this that you see, like this orange crusty guy, like we're going to look at the entire surface of the orange crusty guy. And this is what we do for A. So percent cover that we see on the plate at all. For column B, you're just looking at what is directly attached to the panel surface itself. So like for this orange crusty guy, you can see that part of it is growing on top of another organism on this other yellow guy. And so if we were filling in column B, we would not include what was growing on another organism. For that column B, we are only including what is growing directly on the plate surface. So imagine that, well, you can see this even better in, let's see, the 9-month one. There's a lot of stuff growing on top of other stuff. Like this orange crusty guy is fully growing on another organism. So if you were trying to count for column B, you would not count any of this that is growing on another organism. So that's the distinction there. And if there's still confusion, I go over it in a little more depth in the lab recording, so recommend watching that. And then I also have my office hours tomorrow. So great. Okay, any other questions about post-lab 6 or pre-lab 7?
So in the column A, it's asking us to list the species, and then for the panel coverage, so we're only counting one, not all three. I think that's what I was confused about.
So you're talking about in column A? Or, sorry, repeat the question again.
So for the species names, or it looks kind of different on the Excel. Let me pull it up. It says number of species, so I identified 4. But then when it's saying the percent cover on panel surface, I think that's when I get confused. Like, what exactly am I counting out of the 3?
So, okay, let's get that back up. So you'll be doing what percent of the panel surface is covered total for this one, for this total one that you're filling in for this class data. You'll be doing it, you'll also be having like the individual species overgrowth, but you'll be using that to calculate this kind of overall value based on like what percentage of the panel is covered total and what percent of the cover, like percent total cover is like what is totally being, all that's being covered. And then you're looking at what percentage of that growth is overgrowth.
Overgrowth out of the squares, right?
Out of the square, yeah.
Okay.
So for this one, you're not talking about individual species when you're looking at this overall class data that you're adding to. It's just per panel, how much of the growth that you're seeing is overgrowth.
Okay, thank you.
Yeah. And that would be, so that's what you're getting down here at the bottom. So like total number of species is just how many species you saw, total percent cover is what, adding the cover, then you do the diversity index, And then this total percent on primary surface is from that column B, and then you can get what the total percent overgrowth is for putting on that spreadsheet that you download. But yeah, that's a good question. There's a lot of different boxes to fill out, and it's definitely complicated. So good clarifying question. Okay, so there was one aspect, I guess I can pull that learning tree step back up. There was one aspect of the pre-lab that I thought was definitely challenging that I saw some folks struggle with in the pre-lab. And I think that it was about, one of the hardest things was the trophic cascade concept. And I think we'll talk a little bit more about it, but in this question 13, when they were talking about the urchin barrens, and also above when they asked like, what could you do to increase the number of single-celled plants? What they were talking about is in this system, you'd want to remove the predatory fish because that would increase the filter feeding fish, which would decrease the tiny aquatic herbivores, which would then increase the single-celled plants. So yes, you could, a lot of people said you could remove the tiny aquatic herbivores, but they were kind of hoping for you to see that it's really kind of this top-down system where what you do at the top will affect what happens at the bottom. And it's the same thing with the killer whales, sea otters, sea urchins, kelp system, that when there's more killer whales, so an increase in killer whales leads to a decrease in sea otters, leading to an increase in urchins, which leads to a decrease in kelp. So it's kind of how I like to think about this is like, it's alternating, like every step down, like an increase in the step above leads to a decrease in the step below, which leads to an increase in the step below that. So it's like skipping generations in that kind of way of what goes up, what goes down. So I think that that might have been a little complicated the way I just explained it. So hopefully we'll go through it a little bit more and kind of practice thinking through this. And even when I'm, you know, I had an ecology overview class at the beginning of my grad school and reviewing this stuff too, I still had to think through like, okay, so if this goes up, this goes down, that kind of stuff. So it's definitely just something you kind of have to logic through. So yeah, those were the questions that I feel like people were maybe struggling with a little bit, but hopefully things will become clearer through the lab.
Can I add one before you move on?
Yeah.
Okay, so it's still about post lab 6. So for the value of P1, like the total, is everyone's total going to be different?
For the total cover?
Yeah. Is it like out of 80 or 25? Because each square is 4%, right?
Yeah. So depending on which square, it's out of 100% cover, and you're just going to add for each species. But
dividing it by 100.
Well,
right?
Let's talk about this at the end, and we can go through it a little bit more. Just like look at what you're thinking about and making sure it makes sense. But if it's okay, I think let's start with the lab.
Yeah, okay.
Okay, great. Thanks, Tina. Yeah, okay, so moving forward with, oh, the lab practical, I think I'll talk more about that next week. Okay, so for lab 7, we're talking about trophic interactions, which are really important, kind of talking about food webs and relationships between species and different trophic levels. So just kind of to see if this is familiar to you from the pre-lab, going over what the different trophic levels are. Now, what do you think this big green box at the bottom, what's at the bottom of all the trophic levels here? You can type it in the chat, producers. Yeah, great. So the primary producers are the bottom. So these are like our plants, our algae, what have you, that can, you know, are the primary producers of a lot of energy, and a lot of them get energy from the sun. And they are this big block at the bottom of what we think of these different trophic levels. Okay, and so then oh, sorry, I gave it away. What is the next trophic level above the primary producers? The primary consumers. Yes, who consumes the producers? Primary consumers, great. And then what's next? Who consumes the primary consumers? Secondary consumers, great. Yeah, so the main thing to remember here is that at the bottom you have these producers, primary producers, and then who eats the primary producers? The primary consumers, and then who eats the primary consumers? The secondary. So I think that's easy because consumers are eating producers, and they're both primary, and then what comes after primary is secondary. So you have the secondary consumers after that. And so what is a trophic cascade? So a lot of times we think about how these different trophic levels are really interrelated, and they can have, even though one level might only seem to affect others, because they're kind of built on top of each other in this way, then you can really feel the effects of changes in dynamics at the different levels, from the top down or the bottom up. And a lot of times we think, when we're thinking about trophic cascades, we're thinking about how predators or secondary consumers can affect the primary producers, and how is this cascade, like a waterfall is a cascading down. So what affects the secondary consumers up here affecting those primary producers at the bottom? And so if we think about like the example in, maybe I'll pull it up. Oops, I'll make this full screen and just pull it up again. If we think about this killer whale, sea otter, sea urchins, and kelp example, so we'll just kind of go through that, what I quickly did before, and thinking through how each level is affecting the one below it. So say a bunch of killer whales come into an area. There's suddenly like 1 million killer whales, and they're super hungry. So they eat so many sea otters. Like they eat all the sea otters, or the sea otters are afraid to come there because it's like a killer whale party. And so the sea otters are like, heck no, I'm not hanging out here. They leave. Because the sea otters have left, then the sea urchins that the sea otters eat are now going crazy. They're like so happy. They have no predators because the killer whales aren't going to mess with them because they're too small. So the urchins are just blowing up, and then they're eating so much kelp. There's an urchin party, and they're eating so much kelp. And so now the kelp is seriously depleted. There's no kelp left, just millions of urchins, and that's what we call an urchin barren. So you can kind of be like, killer whales up, skips a generation, sea urchins up. Killer whales up, sea otters down, skips a generation, kelp down. So it's these alternating levels when you have this trophic cascade thing. And the same with these predatory fish. It's the exact same type of system where if you remove the predatory fish, so they're saying if you want to increase the survival of the population of single-celled plants, you take away the predatory fish, then it skips a generation and the tiny aquatic herbivores go down, and so the single-celled plants go up because predatory fish gone, filter feeding fish up, tiny aquatic herbivores down, single-celled plants up. So it's the same type of thing, but looking at those alternating generations is key here. Okay, and so how might the presence, we're thinking about trophic cascades, we're thinking about dynamics between producers and consumers and primary producers and secondary, or primary producers, primary consumers, and secondary consumers. And we're also thinking about predator-prey relationships and dynamics. And just thinking about how might the presence of a predator affect prey behavior. So I kind of put in Roadrunner and Coyote. I don't know if any of you have actually seen these very, very old cartoons, but this is, in my mind, classic predator-prey dynamics, except that the prey is actually really smart and can always outsmart the predator. But I'd say that Roadrunner's activity and behavior is highly influenced by Coyote being there. I mean, maybe he'd be running around, but he'd probably be chilling more of the time. But with Coyote constantly around and chasing him and scheming to eat him, his behavior and his energy a lot of the time is going towards escape. So if there are a lot of predators around, you would probably expect the prey to be on edge, running away, hiding, maybe not focusing their energy on conserving energy or reproduction, but more of their energy is kind of directed towards escaping being eaten. So a lot of times we're thinking about energy allocation and how different stressors might affect prey. And so a change in prey behavior could also influence a trophic system. So let's think of the example of the otters and the killer whales again. So I said at first, maybe the killer whales come into an area and maybe they eat all the otters, but maybe even if they don't eat the otters are leaving or hiding or not hanging out and eating and having fun. Just by changing their behavior, that can also lead to this trophic cascade where the urchins are dramatically increasing in population. So it doesn't have to be that just the predator eats all the prey and they're gone forever. It could just be that their behavior is modified such that they aren't eating as much. And this can also have this cascading effect. So that's what we're hoping that you see here, both seeing an example of a trophic cascade and also thinking about different examples of trophic cascades, and then also seeing how predator presence can affect prey behavior, and even a prey changing their behavior can influence, different trophic levels. Any questions about this? Okay, awesome. So the system that we are thinking about in this lab today is a system with 3 levels. So we've got mosquito larvae at the bottom, and then we have gambusia, or this mosquito fish that eats the mosquito larvae, and then the cichlids, who is this next level, a tertiary consumer. So we don't have a primary producer in this system, but it still holds true that we have this primary consumer, the mosquito larvae, then a mosquito fish, and then above that, this tertiary consumer, the cichlids. And our question, Childish Gambusia, is that would be a great artist for sure. So the big question here is, does mosquito behavior change in the presence of a predator? So in the real lab, you would also be looking at tanks and kind of seeing how these larvae are changing their behavior with the introduction of predators, and then how it changes again with the introduction of a predator of their predator. But we will be watching a video of this, and they're still super cute to watch. You don't even have to feel that bad when the mosquitoes get eaten, because nobody likes mosquitoes. So we have different treatments. The first treatment is just the mosquito larvae alone in the tank. They're just chilling in there, doing their thing. The second treatment is the mosquitoes and the mosquito fish, but the mosquito fish is behind a partition, so they can see the mosquito fish is there, but the mosquito fish can't actually eat them. Then treatment 3 is the mosquitoes and the mosquito fish, and there's no partition, so the mosquito fish can eat them. Then we have this treatment 4, which we'll be collecting data on, but not adding it to a kind of collected group data with the mosquitoes, the mosquito fish, and then the predator of the mosquito fish, the cichlids. And so what you'll be doing with this is creating a time budget for each treatment. And you're going to look at what % of time they're feeding, what % of time the mosquito larvae are swimming, what % they're hiding, and then what % of the time they're breathing. And then I really recommend to kind of I'll do it right now, but once you're actually kind of in the mode of working on this, recommend going through both of these videos again. Let's get it up to show you. So
for just $67, you can make as
that's skip ads. Okay, so basically you have these little, this is the tank, this is the video you'll be watching, and the little mosquito larvae are up there. And I think I can actually make it. Yeah, so 1.5. It'll tell you, see, look, oh, there's a guy swimming, but it'll tell you when to collect the data. So they're just chilling. And then every 30 seconds, I think that there's a bell. Yeah, so it's telling you when to collect the data, like every 30 seconds, to see what they're doing during that time. And then Ivana has added this very pleasant background music for you to enjoy while you are watching them. And I think that it's only going to be for 5 minutes. So I think that video is 20 minutes long, but you only have to watch the mosquitoes for 5 minutes. Because I think 20 minutes is much too long to just sit and watch those little guys swim around, as cute as they are. Oh, but actually, I take that back. You will have to watch for 20 minutes because it's 5 minutes per treatment. So remember we said you have the different treatments are, the different treatments are the mosquitoes alone, the mosquitoes plus gambusia, the mosquitoes plus gambusia with no partition, and then the mosquitoes with gambusia and cichlids. And so for each one, you're going to be seeing how they're changing their behavior after each 5 minute time frame based on the different treatment. You could do it at 2 times speed if you want, or pause it when it's time to make sure that you can count them. I know it's bad, but sometimes I watch recorded lectures on at least 1.5 speed sometimes, if the professor speaks pretty slowly. Okay, so once you, when you're going through the video, at every 30-second intervals, you're going to count how many mosquitoes are doing each behavior. So whenever you see that little mosquito thing show up, thanks for giving you ideas. You didn't hear it from me, but sometimes you can speed up your lectures. So at the initial one, you'll just count, there's 5 little guys in there, and you'll be like, okay, all 5 of them are breathing. And then at 30 seconds, when that little bell goes off, then you'd say, okay, so 4 of them are breathing and 1 of them are swimming. And so for each interval, you're just kind of doing tick marks where each of the mosquitoes is hanging out. So maybe at 5 minutes, 3 of them are feeding, 1 is hiding, and 1 is breathing. At 4.5 minutes, 1 is feeding, 1 is hiding, 3 are breathing. And then you're going to sum up for each activity, how many are doing each thing. So you have 7 feeding over the entire 5 minutes, 7 hiding, 32 breathing, 9 swimming, and that's total 55 mosquito time intervals. I know that's kind of confusing, but it's just adding down and then adding across. And then you're going to have 7 divided by 55. So 13% of the time mosquitoes were feeding, 13% of the time mosquitoes were hiding, 58% of the time they were breathing, and 16% of the time they were swimming. And then I also really recommend this explanation in the intro video for going through this, because as with many of the labs, the first time I was exposed to it, also I found it a little bit confusing. So I'll go through this, and as I've done with the last few labs, we can kind of go into it in more detail after if people are still finding it confusing. So then once you have your, sorry, I froze for a second. Once you have collected your data, you are once again going to be adding to a data sheet that you download with your data and then making graphs. So I went ahead and downloaded this to show you. So this is after you've watched the video and filled out those things for collecting your data and your time budget. Then you're going to have this data sheet that you download with this spreadsheet, and you're just going to add your data from treatment 1 through 4 here, and it will calculate the averages for you. So it's pretty straightforward. So for that first 5 minutes, okay, say they were feeding 9% of the time and hiding 0% of the time and breathing, to make sure this adds up to 100. Swimming 1% of the time and also breathing 90% of the time. So then it gives us the averages. And then, and yours, it should be pretty much the same, like in the same ballpark, because you're all watching the same video, but you know, could be a little bit variation, and these are not official numbers that I've gotten. I'm just putting this in for an example. But once you have these, you're going to be making graphs that are showing a time budget of what percent of the time for each treatment they were feeding, hiding, breathing, swimming, etc. And you can choose to do this how you want to. I like to just put it on a separate sheet, and then you can just like insert chart, and it's pretty simple. And that's another thing that we can go over in office hours more as well. So yeah, here's make a graph, 1 for treatment 1, 2, and 3, and you're going to plot the averages for all groups. So that's that bottom row in the data sheet, the spreadsheet that you download. And you're going to say, is there a difference between treatment 1 and 2, treatment 1 and 3, and then how does it change in treatment 4 with the introduction of that secondary, or they call it tertiary consumer. Any questions about that so far? Okay, I think that's it. So I think then I will go through in a little more detail about the data collection, and then I'll stop recording and open it up for questions about anything. And I have to get off a little bit after 3, but I have some time before then to answer questions. So if you feel good about this, you can feel free to pop off. But if you want to, we can look at this a little bit more too. So let's, wow, I have way too many things open. Lab instructions. Okay, so yeah, so this is for the first, I'll just go, does anybody want me to go through the data collection in a little more detail? Yes. You can say no also. Okay, I'm not seeing anything, but I'm just gonna go through it quickly, just in case. So here is, they also have a practice data collection video for you to go through, but for this, like say this is, you can use this template for collecting data for any of them, but like you'll be watching and then it'll give you the notification when you're supposed to collect the data. So this is for treatment 1 without anything. And then, let's see.
Evidence that the mosquito larvae perceive the fish.
Okay,
Take a moment to really think about this.
so then this is treatment 2. So there's this little barrier in between, and then she points out all 5 are here. So that's where you would have recorded for your initial thing of treatment 2. And then it'll go off every 30 seconds. And you're going to say how many are feeding, hiding, breathing, swimming, or being eaten. None should be being eaten because the mosquito fish are behind a plastic sheet, so they can't eat the mosquito larvae. And then, so now they're going to, there, now all 5 are down there, but they have taken away the plastic barrier. So this is treatment 3 now, and the mosquito fish are just swimming around looking for mosquitoes to eat. So then you're going to do the same thing. Yes, eat those mosquitoes. You don't like mosquitoes. And you're going to do the same thing where you, every 30 seconds, when that little mosquito larva appears on the screen, you're going to say how many are doing these activities. And then there's going to be the final treatment where there's these big guys in here, or this big guy in here, and you're going to see how it changes also. So that's the data collection part of this. Okay, so hopefully that makes it a little bit clearer what to do. And then as with all the other labs, I really recommend watching the videos that they've made for the labs, because they're really, really good at explaining all of this stuff. And then also, as always, I have my office hours Tuesday and Thursday, and you can come and we can go through it if it's more confusing. So with that, I'm going to stop the recording, and then we can go through other questions that folks might have.